Hello everyone, my name is Nurjan Baikalov and the topic of my presentation is how to derive electric energy from the galvanic cells. A galvanic cell is a cell where the chemical reactions between the single conductors connected through an electrolyte and salt bridge produce electrical energy. The galvanic cells harness electrical energy from redox reactions in order to perform useful electrical work. The key to gathering the electrical energy is to separate the oxidation and reduction half reactions, connecting them by a wire so that electrons must flow through that wire. That flow of electrons called a current can be sent by a circuit which could be a part of any number of electrical devices such as radios, televisions and watches. There are two types of galvanic cells. As you can see in this picture, the first type of galvanic cell contains two half cells connected by a porous disc and a wire. As well as the second type of galvanic cell shows the same, but substituting the porous disc by a salt bridge. According to the book of Chemistry Principles of Steven Zundel, galvanic cells contain two half cells, the cathode and anode. Due to the spontaneous redox reactions, anode of galvanic cell is negatively charged and it's the source of negatively charged particles and electrons, while the cathode of galvanic cell is positively charged. The oxidation reaction in galvanic cell takes place in the anode and electrons move from the anode to the cathode through a wire. According to the chemistry wiki site, for typical galvanic cell, copper electrodes are used as cathode materials, and the half cell of the cathode of galvanic cell is filled with the aqueous solution of zinc copper ions. And therefore, when the cell is applied, electrons came from the anode reduce copper ions in the solution to precipitate copper on the copper electrode, on the walls of copper electrode. As well as zinc electrodes are used as anode materials for galvanic cells, and the half cell of the anode is filled with the aqueous solution of zinc ions. And when the cell is applied, the electrons from zinc electrode move to the cathode and form more zinc ions to the solution. The possible electric energy which can be made by galvanic cell is called electric potential. The electric potential is determined by the ability of electrons to gain or to donate electrons. For example, if the electrode of the anode is made of reactive metal, then this electrode tends to give more electrons and faster. While if the cathode electrode is made of the metal with low reactivity, then this cathode electrode tends to gain electrons rather than to donate them in the cell. To sum up, this presentation was about how to derive the electric energy from galvanic cells. Galvanic cell is a cell that derives the electrical energy from the redox reactions in the cell. Galvanic cells contains two half cells with the electrodes and electrolytes, and also the salt bridge and wire. The wire of the galvanic cell is essential for the flow of electrons, which is called a current. This current is used in modern electrical devices such as televisions, radios and watches. The electric potential of the galvanic cell is determined by the types of metal electrodes. So that's the end of my presentation. I hope it was very interesting for you and you can establish your own galvanic element when it's needed. Thank you for your attention.